Okay, this is the standard we're on now, and it's been hard to teach this to you because everybody's been talking so much in class, and I think everybody's excited about getting out of school, and but that's been stressful for me because we have to finish this standard. So the first thing we need to understand about hazards is what they are. So we've been talking about these. They're like hurricanes, earthquakes, tornadoes, volcanoes. And I don't think you have to memorize all these, but you just have to have a good idea of what we're talking about. So all of those are hazards, right? The list goes on. You just need to understand that this is how scientists are looking at these things. They want to know the causes of them, because if they know the causes, then they can be more prepared for when they hit. They could evacuate people from the area. They could also maybe build structures that are more compatible with those kinds of those kinds of hazards that are happening. I was talking to Lauren Savell today after class, and I was telling her that these hazards are kind of like predators. And she laughed and said, "So we're not the top of the food chain." And that's probably a good way of looking at it, because we can't control these things, and we don't like it when we can't control things. So that's why we're like doing everything we can to figure these out, because we don't want to die, we don't want our animals to die, and we don't want our stuff to be destroyed by these things. And so they definitely act like a predator. They take us out like predators would take us out. So we need to, scientists want to know what's causing them. So each of these, we know in general the causes of these things. They're naturally caused. The geological processes of the earth that we just went over a couple standards ago. We know volcanoes, they're natural processes. We know the weather is also a natural process, and climate change has been making it worse. We know that earthquakes happen because of plate tectonics, the plate boundaries where two plates are colliding. When they move, they cause earthquakes. And we see from the graphs that we've been looking at, and the reports online, the maps, that earthquakes are constantly happening. And if they're deeper in the earth, they're not as seriously impacting us as if they're more towards the surface of an earth. So earthquakes that have higher magnitudes are higher intensity, but they also need to be closer to the surface to really be affecting us. Okay, some of the biggest earthquakes are like, I think a student was looking up in Japan, 2011 was like a 9.9 on the Richter scale, which was the largest earthquake ever known. So we look at the cause of earthquakes and the cause of hurricanes, the cause of volcanoes, tornadoes. Like I said, they're all generally naturally occurring, but then we can look at them individually and see what the causes are. Like a cause of an avalanche is deep snow on a steep mountain slope, and that's a recipe for an avalanche. And so that's why ski resorts often blast their mountainsides when in a controlled situation, so they can get rid of that deep snow and eliminate the possibility of an avalanche. And that's because they figured out, okay, this is the cause of an avalanche. And that's the kind of stuff, if we can mitigate the problem, and mitigate means make less severe the consequences. So if we can mitigate the problem, and make it less severe, then we will. And that's one big job for scientists. So finding out the causes of these things. And then the warning signs are, okay, if we understand what happens before these huge events happen, then we can evacuate the area. For example, warning signs of a volcano are that you can see puffs of smoke that come out of it. And then also there's like Mount St. Helens had a bulge that was growing on one of its slopes. And there were scientists or geologists watching that. And then one day it just blew. And the whole side of the mountain, that's when it had a landslide, right? In combination with that eruption. So that bulge basically, was one of the warning signs. So the smoke, the bulge, and then earthquakes, small earthquakes, tremors, and above that are also warning signs that a volcano is going to erupt. And then in the Kilauea, I'm not sure if I'm saying that right, but in that volcanic eruption, there was a crater that collapsed inward. So not just a bulge, but a crater that collapsed inward. That was a warning sign. Tornadoes also have warning signs that we have figured out. The sky gets kind of greenish. There's high winds and rains. And so we're able to broadcast alarms in communities and give people a chance to get to a safe place. So maybe the hurricane or the tornadoes will take out our property still, but they won't take away lives, which is a priority. Okay, and then scientists also, this is a big one. This is where the maps come in. Scientists study past occurrences of all of these natural hazards, and they plot them on maps. So if, on earthquake maps, they'll plot where the earthquakes have been, and they'll track them over time to see if there's any time patterns. So they'll see if there's location patterns and time patterns. And when they have that, then they often predict when they think the next earthquake is going to be and where it's going to be. And they have done that in Utah, and scientists predict that Utah is due for a major earthquake, and they've estimated that place where it's going to hit is Brigham City. That's a likely possibility. And so that's the kind of stuff they want to do. And so once they have those understandings, that we can at least prepare. This whole mitigation or prevention of death or reduced property damage, you could do that with earthquakes by retrofitting buildings. We talked about in class base isolation systems by installing that underneath buildings so that it counteracts the seismic energy waves that flow through the earth and cause whole buildings to move. In Newton's laws of physics, that would be accelerate. The waves are a force, and they cause other objects to move or accelerate, which means change position or change speeds. And we don't want that to happen with a building, right? Because it's going to crack and get destroyed and fall down. And so if we can absorb those energy waves and, redirect them out into a different place that won't cause damage, then that's what scientists are trying to do. And there's a lot of smart people that are figuring those types of things out. And that's what they've done to the Utah State Capitol building. They've retrofitted those buildings. So that's an important thing for you to know, that one of the biggest things that in figuring out how to protect our property against earthquakes, scientists have said you've got to find materials that are both strong and flexible. So they've worked that out with that base isolation system. And then they have braces that they use that they're diagonally placed in buildings next to walls, and they usually like to use a material steel. Steel is both strong and flexible. But they used other items too. They used pillars. Sometimes that's used decoratively, and like in the old South, you see pillars on the outside of houses. But they are also to increase the stability of a building.